Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B1008, is triggered when there is a failure in communication between the Multiplex Integrated Control Unit, MICU, and the gauge control module in the vehicle. This issue typically affects the dashboard's ability to provide accurate vehicle performance data such as speed, fuel level, or engine temperature. The MICU is located in the under-dash area and serves as a central controller for various electronic systems, including communication with the gauge control module. This module, in turn, relays important information to the driver through the dashboard indicators. When the communication failure occurs, the driver may not receive crucial alerts about the vehicle's status. It's essential to troubleshoot this DTC promptly to ensure the vehicle operates safely and effectively. The DTC B1008 indicates a communication problem between the MICU and the gauge control module, particularly with the automatic transmission (AT) message. The MICU, located in the under-dash area of the Honda Civic, manages multiple electronic functions of the vehicle. The gauge control module is responsible for displaying critical information about the vehicle's operation on the dashboard. When the communication link between these two components fails, the gauge control module cannot receive or send the necessary data for accurate readings. This communication issue can result from various causes, including electrical faults or faulty connections. Addressing this error requires a thorough understanding of both components and their functions within the car's electrical system. A variety of factors can lead to the occurrence of DTC B1008. One common cause is loose or poor electrical connections, particularly at the 36P connector of the gauge control module or the 16P connector at the under-dash fuse/relay box. These connections are critical for communication. If they are compromised, the entire system may fail to relay information properly. Additionally, issues with the vehicle's battery condition may affect the functioning of electronic modules, potentially causing interruptions in communication. If both the connections and battery condition are intact, it may point to a faulty MICU or gauge control module. Identifying the exact cause is essential to restoring normal communication and function. When DTC B1008 is triggered, drivers may notice several symptoms that may affect overall vehicle performance. One prominent symptom is inaccurate readings on the dashboard gauges. For instance, fuel levels may appear wrong, or temperature readings may not align with the actual conditions. Additionally, the dashboard may illuminate warning lights, alerting the driver to potential issues that require attention. This lack of accurate information on vehicle performance can lead to misunderstandings about the vehicle's operational status, posing a risk to safety driving. Overall, these symptoms require immediate diagnosis and troubleshooting to mitigate any long-term issues. The first step in troubleshooting DTC B1008 involves using the Honda Diagnostic System, HDS, tool to clear any existing Diagnostic Trouble Codes, DTCs. Clearing the codes is essential as it resets the vehicle's system so that new data can be collected after this process. Once cleared, the technician can then work to determine if the DTC reoccurs. This initial step helps in identifying intermittent issues that may not appear consistently. If the DTC clears and does not return, this often indicates a temporary problem rather than a permanent fault. After clearing the codes, it is crucial to follow the subsequent steps to ensure a comprehensive diagnosis. The second troubleshooting step involves manipulating the ignition switch. Begin by turning the ignition switch to the lock position, subsequently moving it back to the on/to position. This sequence ensures that the vehicle's electrical systems are reset and ready for further testing. It's essential to wait at least 6 seconds in the on position to allow for the system to initialize fully. This step is crucial because it prepares the electronic systems, enabling them to communicate effectively. After completing this step, the technician should check for the presence of DTCs again, determining whether B1008 is still indicated. In the third step of troubleshooting, the technician should recheck the diagnostic trouble codes using the HDS tool. It is critical to determine if DTC B1008 is still indicated. If B1008 is present, it signals that the communication issue persists and additional investigative efforts are needed. If, however, it's not indicated, this suggests that the original error may have been intermittent or have cleared up on its own. Should the code reappear, the technician must proceed with further testing protocols to diagnose the root cause effectively. Documenting the status of the DTCs is a vital part of the troubleshooting process. The fourth troubleshooting step focuses on checking for the presence of other DTCs, specifically B1011 and B1032. If these codes are also indicated alongside B1008, it suggests a more complex issue related to communication within the system. The technician should check for an open in the communication circuit between the MICU and gauge control module. An open circuit could be due to damaged wiring or faulty components, which would need immediate rectification. If the circuit is indeed compromised, appropriate repairs or replacements must be made. On the other hand, if the circuit appears intact, it may point towards a faulty MICU, necessitating its replacement to restore proper functionality. In the final step of this troubleshooting process, the technician is directed to conduct an input test on the gauge control module itself. This entails evaluating the performance and functionality of the gauge control module. The input test will provide insights into whether the gauge control module is functioning correctly and effectively communicating with the MICU. Should this module show signs of failure, repairing or replacing it may be necessary to resolve the DTC B1008 issue. Verifying the functionality of the gauge control module is crucial because it plays a pivotal role in delivering accurate vehicle performance data. Ensuring this component's reliability can mitigate future communication problems with the MICU. Final repair verification is a critical phase in the troubleshooting process for DTC B1008. After making any necessary repairs or replacements, it's crucial to confirm that the work was successful. This can be achieved by rechecking the DTCs using the HDS tool to ensure that no related codes are present. Once confirmed, a comprehensive test drive of the vehicle is essential to monitor the functionality of the repaired components under actual driving conditions. By following this step, the technician can ascertain that the communication between the MICU and gauge control module is restored effectively, allowing for accurate gauge readings. Successful verification ultimately ensures the vehicle's reliability and safety for the driver. To prevent issues similar to DTC B1008 from recurring, implementing routine preventive maintenance is crucial. One essential practice includes regular inspections of all electrical connections within the system. Ensuring that connections are tight and free from corrosion can help avoid communication failures. Additionally, monitoring the battery condition regularly plays a significant role, as battery health directly impacts electronic systems. It's also advisable to keep the vehicle's software updated periodically, as manufacturers often release patches that can enhance communication protocols. Overall, maintaining these components and practices can significantly reduce the risk of encountering DTC B1008 or similar errors in the future. In summary, DTC B1008 highlights a communication loss between the Multiplex Integrated Control Unit and the Gauge Control Module in Honda Civics manufactured between 2006 and 2011. Understanding the roles and locations of these components is key to effective troubleshooting. Throughout the diagnostic process, careful inspection of connections, battery health, and error codes is crucial to identify the source of the problem. Following the outlined troubleshooting steps can help ensure accurate diagnosis and repair of the vehicle. Implementing preventive maintenance strategies can also significantly reduce the likelihood of encountering similar issues in the future. Understanding these dynamics is fundamental for the efficient operation of the vehicle's electronic systems. Please like and subscribe to the channel. See you next time.